So, a little bit about me. I'm Sutyak. I am the lead AI developer of Sanctuary Software, and my talk is called Computer Vision: Lessons from the Past, Signals for the Future. So, the point of my talk is going to be going into some of the history of AI and ML, and then trying to predict the future, and then I'm going to go into some things that you can do now practically. So, without further ado, there have been three major waves of AI that are generally agreed upon. It's widely debated which wave happened when, but for the purposes of the talk, I have said that these are the three major waves. So the first one is Deep Blue. Deep Blue shows that humans can beat, AI can beat humans at chess specifically. This is something that was not previously thought to be possible. They use brute force search, no machine learning whatsoever. Then the next major wave, which is where it gets more interesting, was AlexNet. AlexNet was a computer vision system built to solve ImageNet. ImageNet is a competition for classification, image classification. They blew everyone else out of the water. They did this by leveraging large neural networks and GPUs. They were actually the first people to use GPUs well. So, for example, on the right here, I have a picture of their system, which is their high-rolling system. They did two GTX 5080s. They are the reason that NVIDIA is a $5 trillion market cap right now. But yeah, they did this as well using, they marked the rise of supervised learning with large labeled data sets. So the idea with supervised learning is you take an input and you map it to an output on your neural network and back propagate, right? And so the thing about supervised learning is generally the model is very task specific. So that AlexNet in this case can only do image detection. So the next major wave was ChatGPT. ChatGPT was created by OpenAI. We all know about it. Fastest growing app ever. What actually makes ChatGPT different is that they use the transformer architecture. The transformer architecture was so powerful that in a lot of cases, for like 5 years, transformers were applied to like every single research problem, and people were like, okay, performance 20% better. And that was like 2017 to like 2022 is pretty much every single machine learning paper was like that at that point. And then they also did large-scale pre-training on diverse text data. And so GPT in ChatGPT stands for generative pre-training. And generative is actually a reference to generation. And so I think this should be more general pre-training, not generative pre-training. The reason is because they trained their model on general data, pretty much the entire internet. So this one general model can perform thousands and thousands of tasks. And the key insight here is that being able to perform tasks that aren't your own is actually extraordinarily good for your task. So knowing what your task is not is actually really, really important for performance. So where do I think Wave 4 is going? Well, I think we're going to go back to computer vision. Wave 3 really shoved computer vision to the backside, and everything that's not language at this point is being treated as a second-class citizen, in my opinion. The reason I think this is because transformers and large-scale pre-training, this general pre-training, transfers really, really well conditioning. And they can be used as foundational models. So I think in the future, we're going to see the vision models being applied to things like world models and and for robotics. But the reality of it is we're kind of already here, right? We already have generally pre-trained transformers for vision. The thing about it is ChatGPT has this unique, ubiquitous task that is chat. Everyone understands what chat is. Whereas computer vision, the model, the actual downstream tasks are very, very bespoke. They're very unique to the system. So the current meta, in my opinion, for getting state-of-the-art performance is using pre-training. So I think you should leverage pre-training as much as you possibly can in order to get better performance. So on the right here I have Meta's AI CapEx at this point. Their entire point, and they're spending hundreds of billions of dollars now in AI, and they're releasing a lot of their research for free. You should be leveraging as much of their performance as you possibly can, not just in all-around, but in computer vision. But the reality of it is, Wave 2 still dominates computer vision. The reason is because the tooling is so mature. You can use YOLO with ultralytics, and you don't even have to touch PyTorch at this point. All you have to do is you have to get your labeled data sets and then pretty much hit enter or get into a specific format, and it pretty much does everything for you for simple tasks like classification, object detection, and mode detection. These things are really, really, really mature and easy to use. So I propose that you should change your thinking a little bit though. I want you to stop thinking, I need to train a model for my task, and I want you to start thinking, what pre-trained visual intelligence can I leverage for my task? The 20.6 flow, in my opinion, should be you start with a foundational model, and for some of these text-based models, you actually already have solved your task. So if you're using something like a vision language model, for example, if you prompt it, if it's smart enough, it'll already solve your task. Then if you need to, later, you may be fine-tune something on top of it, or fine-tune the model in general, or enter it into your long computer vision pipeline, or at the last resort, you go to training from scratch. So the practical workflow here is to, I will propose some practical workflow here. So the idea is you want to define the problem at first, and then you identify your modalities, and then you map the path to the task type and a baseline. So defining the problem is pretty obvious, right? Defining the problem is pretty obvious, right? All you want to do is you want to figure out what you want to define and what you actually want to automate. And then you want to define your modalities. So your modalities are things like image, video, depth, whatever. You want to map your input to, you want to figure out what the actual inputs and outputs you want to get out of your model. And then you want to map to a task type and a baseline. So what this actually looks like in practice is you're trying to figure out what your task is actually called in research. Because a lot of times in engineering, the only thing that matters is figuring out the actual name of it. So you can Google like classification or object detection or pose detection or segmentation. These are there's a lot of deep depth research, and figuring out what your actual what the state of the art is much easier once you've identified that. And then you want to figure out what pre-trained intelligence you can leverage after that. So these are the foundational models that actually matter. And so I've come up with 3 practical examples of this. So the first one is semantic search. So the problem here is radiologists want to search a large medical imaging archive using natural language instead of fixed labels. So think millions and millions and millions of images where none of them are labeled, there's no tags whatsoever. You want to be able to prompt, text in, and get the relevant images out. The classic search problem. So your modalities here are your text in, and then relevant images out. And then your task type and foundational baseline are semantic search. And then the foundational baseline is using a CLIP-based model. CLIP stands for computer language image pre-training, I believe. No, contrastive language image pre-training, sorry. It's a CLIP-based, it was made by OpenAI in, I think, 2017, and the entire purpose of it is to map images to text and find similarities. And a hidden thing that you can also do with it is map images to images if find relevant images. So if you find an image that you want to find relevant images of, you can do that. And the model that I have identified here as perception encoder, it is a clip-based model that I've seen that is far and above everything else. Meta made it, and they kind of didn't have much press about it. And honestly, it is very, very good at like almost everything in this domain. There's other clip-based models that I think are that are also usable, but perception encoders I think is the best. So the next problem I have here is fine grain recognition. The point of fine grain recognition is it is a classifier-based problem. So with generic classification, you're thinking, how can I identify this dog, cat, bird out of this image? Whereas fine grain recognition is more species of dog, species of cat, species of bird. Right? You're trying to get your image in, and you want to get your classification label out. That's your modality. So an example here is finding early signs of cancer and tissue life where differences are subtle. Now this was possible before in Wave 2. You can train an end-to-end system on some fine grain recognition types. But the reality of it is Wave 3 has brought in some more data efficient methods. And so if you have the same amount of data, you can get higher performance, or you can use less data to get similar performance. The way you can do this that I've identified is with DynaV3. So DynaV3 is another meta model. They use, so Dyno takes images in and it gets an output feature in the form of an embedding, and then you use that embedding to then train a small classifier on top of it. And that so you still have this supervised learning end-to-end task, but you are leveraging this pre-trained visual intelligence that Dyno already understands. Okay, and then my third problem I have identified is profitable segmentation. So an example problem here is doctors need to quickly outline tumors or organs and scans without manually drawing boundaries. And so the modalities here are images in, and then image and prompt in, and then you keep segmentation mask out. And so on the right here, I have shown my profile picture, and I added the label handsome man, and that is on the leftmost one. And so you can see that the mask covers the handsome man in the photo. And then on the rightmost photo, I have it prompting ugly man, and there is no mask, there is no ugly man in that photo. So I mapped this to the task type of promptable segmentation, and then the foundational baseline is segment anything, which is a third meta model. So remember how I showed that $100 billion in AI capex, they're not doing too well in the natural language processing part, but they are doing very, very well in everything else. Their research is phenomenal. And so I'm going to open this up for questions, but largely I've identified painstakingly, I've gone through a bunch of different task types, and I identified a simple / edge case for think Wave 2 style way of solving the problem, and then a foundational base, so think Wave 3 style of solving the problem. And so the simple is going to be good for things like being on a Raspberry Pi or a microcontroller, whereas the foundational is you're really trying to push the upper echelon. And that's my talk. So any questions?
Have you done any looking at images of cars?
Images of cars.
That have been in accidents.
That have been in accidents. I've done oxygen detection on cars quite a bit. That's pretty much a solved problem with YOLO, but not specifically like fine grain detection with like figuring out how someone, like how the car crashed. Is that what you're asking?
No, like the difference. So by VIN number, I can tell exactly what that car should look like other than color. Right?
Oh,
From an
okay.
outside point of view, and then I can look at the crash pictures and note the differences.
I haven't looked at that problem specifically, but that's like that would be a classification problem, no?
Yeah.
Okay. Yeah.
So
So
family is interesting.
I haven't looked into that, no.
Okay.
Go ahead.
Each of the three waves has like a classic problem that was solved, like will AI ever be humans at chess? Can you tell if there's a cat in the Do you see something like that similar for Way Forward? Do you see a hard problem that we're on the cusp of maybe solving, something that is right in line of sight for this next wave?
Yes, it is, can a robot clean your house? That is my way for prediction.
So just a follow-up question. I have two ways to do this. One is just static video, and then the other is maybe more like a spatial intelligence. Do you see this as needing to be coupled with spatial intelligence? Like these kind of go hand in hand?
Yes, 100%. I think my personal prediction is that way forward is going to be robotics and world models, and the reason I think it's going to be really important for these world models to understand physics and actually understand how the world actually interacts in order to be able to have a robot clean your house. This is a very general path. Another question?
So in traditional ML, there are things called groups of models that you use together, kind of an ensemble model. I've seen graph ML used in some of these to get different sets of results. It's like have you seen anything with graph ML?
Graph ML. So are you talking about
relationships?
Yes. So are you you're talking about fusing different ML models together specifically?
No, specifically, just looking at it from a graph perspective, a graph would look at the relationships between everything that's part of the content, and then mapping those relationships and finding these. So one of them, somebody here is using graph ML to do basically predictive of how the injection mold should be developed. At work, I have a friend who, outside of work, is doing graph ML on images of hearts and lungs for cancer detection. Way better than anything else. It's way past everybody. Cool. So I was wondering if you had looked at any of that.
No, none of that for me. I haven't developed that. Okay.
What do you mean by world model? I hear that word used, but no one's ever given an affinity.
Yeah, so there is something like, are you familiar with dynamic theory or anything like that? Okay, so the idea with these pre-trained vision transformers is they are self-supervised so that they can learn on unlabeled data. And so with a world model, it would be self-supervised on video of pretty much the world, right? So it could learn actual physics into its so it can actually understand the world around it. So using video instead of just images. And so we have tons and tons and tons of video data, and then on top of that, we will eventually be generating simulated video data that has slight augmentations, and all of that can be fed into the model so that it can predict pretty much the next frame of a video.
So how will that play out with the physics engine part of it?
It's not necessarily a physics engine, it's that it actually understands the physics within it. Does that make sense?
Yeah, well, one thing about what he gave with the car example, when you were training on the video where you're looking at car accidents where you actually have a video of two cars colliding.
Yeah.
How would it handle that to understand? So whenever you produce it, it's not like one goes through the other or as those two entities meet. You know what I'm saying?
Yeah, the way I like to think about it is that LLMs, they predict the next token, right? And to predict the next token, you have to understand what you're talking about, what's the actual content that you have to understand. In English language, you have to understand the facts within whatever you're saying, right? Whereas a world model will be able to predict the next frame. So you would have to actually understand the physics to predict the next frame. And so you could use that, the intelligence within that, to then go to downstream tasks like robotics.
What would you say is one of the, I guess you say, better world models that somebody could play with right now?
World models kind of suck right now, in my opinion, but there's...
the best of the worst, however you...
Best of the worst? There's video generation models that are okay. They're not too bad. They can do visually stunning results. I think Google has a couple of them. I'm blanking on the actual names of them, but...
is video considered
Yeah, I would say video is a good one, but that's less of a world model and more of a generation model. It's not really built for downstream tasks, it's more for, I'm generating a video,